Hello.
Hello. Hello, can you hear me?
Yes, I can hear you.
Perfect. Yes. So we have an hour together. I thought we could. I have a couple problems prepared today,
Okay.
and before we get started, I want to get a sense from you if you prefer a more harder problem or maybe an easier problem. It's really about how it can help you improve in this interview. So, what would you prefer?
Yeah, I would. I am trying to prepare for on-site interviews for the one of the four big companies. So I would prefer something more similar to that kind of level, which I guess it would be something more to between medium and hard, something like that.
Sure. Yeah, even the medium type questions have a big range. But that being said, let's start with one question, and then after that, you can tell me if you prefer something harder, and then we can kind of go from there.
All right.
Okay.
Sounds good.
All right. So I've got this question here. Do you want to pick the language first that we will be using?
Sure. I can use Python 3.
Perfect. Yep. All right. Okay. So I'm just copying the question here in the top. Here's the question, and let me see if I can get an example here for you. There we go.
Hmm. Okay, so we have an array of integers. They can be negative or positive,
Yep.
and we're looking for three different numbers in the array that sum up the closest to the target, and we return the sum for the total sum of the three numbers, which in this case, okay, for the example, it is -1 plus 2 plus 1 equals to 2, and that is the closest we can get to 1. Let me see other examples. I guess if we do -4 plus 2 is -2 plus 1 is -1. Okay, yeah, but 2 is even closer. Okay. Okay, I guess. And you can assume that each input would have exactly one solution. Oh, okay. Okay. Let me see. So we want to get the sum of three numbers that are the closest to the target.
Yeah.
So what if we had the problem where we are looking for three numbers that sum up exactly the target? That I think okay, I think that would require us to do some kind of like one loop through the entire array, and then each value will be stored in some kind of map where the key is the value in the array, and the and actually the problem doesn't require us to return the actual values. So okay, but let me see.
Yeah, I think you have a good start here by thinking about what happens if we are looking for the exact target, right? So I think that's a more simple approach. Simple solution if you could get that, and then after that, then you could extend to how do you get the closest.
Okay. Yeah. So it would be basically looping through the array, storing the values in a map or even a set, I think would work. Or no, I think we still need to know the indexes because we don't want to repeat the numbers. Is that actually a good assumption? Because I'm assuming that I cannot use the same value twice, right? Is that correct?
That's a good question. In this problem, I think let's make it easier. Let's say no, you cannot reuse the same number twice. Because if you can, then I think you can easily get the exact target, right? So let's say you cannot use the same value twice. And you can also assume there are no repeating values for now.
And non-repeating values. Okay, that's good. Okay, then
No repeating values and no cannot reuse values.
Cool. So yeah, basically what I'm thinking is in this map, I would have what are the values that we have in our array and their corresponding indexes, which then that will help us to do a second iteration. And since we are looking for actually 3 numbers, then I think we will have to do a nested for loop. Because we will have to find 2 different values where if we subtract the sum of those 2 values to the target, and if that result is already in our map, then that means and if the index of that value in our map is different to the 2 indexes of our 2 candidates, then we have found a combination of 3 different numbers that sum up to this target. Not sure if that makes sense.
Yeah, I think it does. Let me try to repeat what you said to make sure I understand fully. So you go through one iteration, and then in that first iteration, you put the value and the index into a map. And then in your second, so within that iteration, you will go through another, maybe 2 iterations to find the combination of 2 numbers that would, together with this first iteration, sum up to be the target or closest to the target, right?
That's correct. The second step would be 2 for loops, 2 nested for loops. One inside the other.
Right. So in total, in your algorithm, what is the time complexity?
That would be so the first step is linear, and the second step is quadratic step. So, but in total, the total runtime it would be n squared.
N square or n cube? So I'm just trying to understand. It sounds like there's 3 loops in total.
Yeah, but the first loop is independent from the other 2.
Right. I got it. I understand now. Yeah. So it's n squared, right?
Yeah.
So overall, it seems like you have an n squared solution then.
Yeah.
Right. Yeah, that would work. I think that would work.
But yeah, the thing is now, if we want to adapt that solution to the original problem of looking for the closest
yeah. So the good part about this problem is you don't need to know which 3 numbers, right? All you need to know is the sum and track that it's, output the sum that is the closest to it, right? So maybe that can reduce some complexity.
Okay. Then if I can somehow pre-compute what are all the different sums of 3 numbers, and then no, but that would actually require another loop inside our nested for loops. What if? Okay, so what I'm thinking right now, I'm not sure if I'm going towards the right approach or not, but what I'm trying to think is, okay, what if so we are in this nested for loop where we are basically iterating over every single element, and then for each of them, we're gonna iterate again through the array. So we have two numbers at this point, and then we're looking for that third number, and then at that point, we're looking for the closest that give us the target.
Okay, so if I understand your algorithm, you are effectively testing out all the combinations there are, right? And to find the three numbers that would sum up to the target.
Yes.
And for this problem, instead of equaling to the target, what you can do is look at the difference, right? Track the difference. If this difference is smaller than the initial difference, then you can store that sum, right? So in this case, in the example here, the output is 2, right? And your program would output 2. So somehow along the way, as you are visiting three numbers, you get the sum of 2, and then you store that 2 because that is your best solution so far, right? You can also get -1, which is another combination, but that's not as good as 2, right? Because 2 minus 1 is 1, but -1 minus 1 is -2, right? So you store the sum that has the smallest difference, and you keep that with you until you exhausted all combinations. Then you can also get that sum, right?
But that would be a cubic algorithm, right? Because we will have to go through every single possible solution.
Okay.
So we will.
Okay.
So we would that algorithm would be n to the 3. Is that correct? Or probably I'm not thinking about it correctly.
Yeah. You can always do better. So here's another idea here. So far, you have the best solution of n squared. If we're simplifying the problem to find a sum, the three sum that is equal to the target, right? The best solution that you can find is n squared. Now, if the solution is already n squared, you can do some operations on the input set without impacting the complexity further, right? So there are things you can do, given that you already have an n squared solution. For example, if you sort the array, you're not hurting the complexity overall because sorting the array is still less than n squared.
Right.
Right. So let's say you sort the array, or right. Let's say your input is already sorted, right? Because that's already not relevant enough to your algorithm. Then how can a sorted array help you find this solution?
Okay.
You think about that.
Does maybe that help to maybe do a binary search when we are looking just for the third number? So let's say that we have maybe yes. I mean,
so binary search helps you find one number, right? It doesn't help you find two numbers.
Yeah, but what I'm thinking is that what if we are I'm thinking the scenario when we are already inside our nested for loop, which at that point we already have two numbers,
right.
and we are looking for the third one.
Right.
So it works. So it is kind of straightforward when we are looking for the exact sum of the target, because at that point it is just a matter of like subtracting the sum of the two numbers that we have with the target, and we just look for that missing part in the map. But what I'm trying to think is, what if we, instead of looking in the map for the specific number that we are looking for, what if we do some kind of binary search at that point, looking for that third number? Like, for example, let's say that we have, in this case, maybe our current sum is -4 and -1, which it is -5. So at this point, we're looking for that third number that get us the closest to 1. So we know that we are looking for a number that is the closest to 1 minus 5, which is wait, is that true? Yeah, it would be 6, right? We are looking for a 6 at that point. So at this point, what would be the closest number? And so saying that our current possibilities is starting from this index. So since this piece of the array is already sorted, we can look for what is the closest to 6 in this part of the array. And of course, since we don't have a 6 here, we're gonna say we can do some kind of binary search that gave us the closest number to our target. In this case, it will return 2, which that's what we are looking for.
Right.
But I'm not completely sure if that will work, because let me see.
I think it will. I think basically improve your algorithms from n3 to n square log n, right? I think that's at least a little bit better, right? Because you still have to iterate through the -4 and the -1, and then you do a binary search on the rest, which is an improvement. So that's a good step forward. But I think you can do a little better than that too. And I think that because this problem is not exactly the same as the 3-sum problem, where you find the sum that equals to the target, you may have to kind of come up with a completely new algorithm in a sense that you have been thinking of this map, right? And then I think the map help kind of makes you use the binary search approach to make it all work, right? But if you start without a map, right, you may be able to come up with another approach that may even be better than n squared log n, right? So without thinking of a map, right, of using a map, and then knowing that you have a sorted list, right, how will that help you? Maybe think about how that can help you to find out the 3 numbers. So let's say you start with -4, right? And you're going to iterate through the array. So you start with -4, you do something, and then if it doesn't work, you go to the next one, -1, and then you again do something. But let's say you start with -4 here, and then the remaining list is still a sorted list, right? So you always have a sorted list to work with, right? So what are you going to do here? So basically, I guess the question is, given -4, right? Given -4, find the 2-sum so that closest to the target. And how
so
would you
target -4, I guess.
Well, target is 1, right? Target is equal to 1. So you have -4. That's part of it. Yeah. So actually, you can put that together, right? Maybe find. Okay. So if you're given 4 and the target is 1, so I guess the question now becomes find the two sum closest to 5, right? That's the same problem, right?
Yes. Closest to 5.
Yeah.
Oh yes,
so,
because sure.
So this is the problem here. This is obviously a subset of the problem, right? Like you're given -4. So how do you find the two sum of a sorted list, right? That is closest to 5. What would be this solution? If you can figure out the optimal way to do this, then I think you're closer to the optimal solution of the overall problem.
Thinking that we can start probably with 2 pointers, like given the fact that the subarray is sorted, then I think we can start with 2 pointers, one at the very beginning and one at the end. Say that, for example, this is the first pointer and this is the second pointer, and then in that case we're looking for a 5. So we're gonna say, okay, we have at this point 2 minus 1 is 1, so we need something greater than our current sum, and since we know that since the array is sorted, then we increment this pointer to the next value, which in this case would be 1, and then so of course this sum is greater than the previous one. So now we have 3, and I think at this point we can. So this will be our base case, or this will be the end because we don't have any more numbers, and so it will be these 2 numbers, like that will be the answer. 1 and 2 are the closest to 5.
Right. So in this iteration, your answer would be -4, 1, and 2, and that would be -1, right? So that is, not the closest, but it's the closest given this iteration, right? So next we would do is, given -1, then you can kind of continue that process, right? So with this approach, what do you think the time complexity is?
That is n square, but it is. That is n square over 2, which it is still n square, but it is definitely faster than n squared times log n. So that this is I think this will be O of it is O of n n squared over 2, but in general, this will be equals to O n squared.
Yeah. So I think that's a good solution so far. So obviously there's more to it than you have to keep track of the closest difference throughout all the iterations. So I think you have all the pieces right now to kind of put them together. I think it's a good time to start coding this up, and then kind of run through a couple tests to make sure it works.
Right. Okay, I'll do that. Okay, so we're gonna start with a function that is going to and then we're gonna have a input, which is an array, which it is a list of integers and we also have a k, which is a target. Then this is going to return an integer. Okay, so what we're gonna do is we're gonna have a response, and we're gonna keep. Okay, so this is going to be the final answer. So this is going to be initialized with an infinite number, and then we're gonna do a for loop, which is going to start with I in range of length of array, and then for I in range of the length of the array, and then we're gonna say for each number we're going to find okay, I think that it is fair that we leverage a different method to do like the second step of like having the 2 pointers and doing
Yep.
like the sum of the 2 numbers.
Yep.
Oh, wait, actually, can I assume that the input of this method is already sorted, or should I sort it?
I think for completeness, you have to sort it yourself, because the input should be what the question is given. You can just call a one-liner. You don't have to input in the sort algorithm. Because, yeah.
I can just probably do alright. That's sort. That's it.
Yeah.
Okay. And then what else? So for each number, okay, we're gonna take okay. Okay, so we're gonna say ref equals to max between ref and max. No, to some method, which would be array in I plus 1 to the end, and k would be k minus array in I. One second, because three, and then okay, then this will be array in I plus. So let me explain what this is doing. So, well, I think I can actually explain that after I implement the toSum one. So it will also receive an array and a k, and this going to return an integer, and then it's gonna say, okay, we have a equals 0 and b equals 1 of array minus 1. Why is this? I don't know why that is highlighted, but okay.
Yeah.
I don't know.
It says undefined name list. The comment says undefined, undefined name list. Yeah, I'm not very good with Python myself, so I don't know if it's list or should it be like lowercase. Or...
No,
If it works, that's
No,
fine. Yeah, you can ignore it for now.
that's weird. Yeah. Okay. So one is pointing to the first one. The second is pointing to the last element. So we have our current sum, which it would be actually. Let me think about this. So um, keep. We're gonna keep. So let me see. While A less than B, we're gonna keep doing this, and current sum would be actually this equals 0. So this would be array in B minus array in A. So here we're going to decide which index we're going to move. So if current sum is greater than our target, then we're going to increment A. Okay, so what if it is equal to K? What's going to happen? If it is equal, then I think we just return course sum, and then we do this while and then we're gonna say that okay, so at every single step we want to at every step we are getting a better answer, I think. So
I wouldn't say that for sure. I think you may arrive at the answer early on in your two-pointer loop. So I think it's important to keep track of the difference at every step, and then just store that difference so that you can go through everything, but then make sure that you store the difference. So make sure you keep track of the minimum difference. Right.
The minimum difference?
Yeah, the minimum difference between your K and then the sum, right? You're doing a sum, right, of your index A and B, right?
Oh, right. We want the sum. Okay, sorry. Yes, of course.
Yeah, so I think even line 47 seems a little suspect because it's like the difference between the two, but you're looking for the sum of them that is closest to K, right?
Yeah, right. That's true. Okay, yeah, sure. Then we have our current sum, and then we want the best one. So rest is going. So if K minus current sum is less than actually, since this is going to be And then let me see. Okay, yeah. So this is wrong as well if the current sum equals to equals k. Oh, well, actually, we can just, I think we can get rid of this thing, and then we can just return ref at the end. Let me see, I feel like I'm doing something wrong here. So, okay, this function is looking for the two numbers that are like where the sum of them is closest to, yeah, the sum is closest to k. Okay, so so we keep track of the difference, but we actually need the we need the sum. We need the yeah, we need the sum. We need to return the sum. So okay. Okay, what about this? So now, yeah, we are starting our pointers left and right, and then we check the sum of those two. We check the difference between the yeah, between our target and the sum, and if if that is better than what we have previously have, then we store that as our best answer, and also we we assign the current sum to the final response, and then we continue by doing the comparison at line 53, saying that if the current sum is yeah, if the current sum is greater than k, then we if the current sum is greater than k, actually we need to decrement d.
Yeah.
And the other way around.
Yeah. Yep. Yep. I agree. One thing to point out though is the difference there, the diff value. Just think about that. Do you think you need maybe the absolute value around that, or maybe you can think of some corner cases where that block of code, the line 4951, could that be a problem? Right? Think about that. Uh,
Maybe with negative numbers.
Yes. So what I'm thinking of is, let's say your diff value here at this point could be minus zero point 0.5, right? Let's say. And then in the next round, the K minus curve sum could be 0.5, could be equals to, or say 0.4. Just, for simplicity. I know this won't be like decimal here because we're all dealing with but then your positive will be less than your negative, right? So it's that idea of absolute values that I think can become a bug depending on the input. So something to think about. I think you can handle that.
Yeah, since we have the option of having negatives, then and we are looking for the closest to the target. So I think we need the absolute value of the difference, because we want to know this difference, how far is from our target.
Right.
And then we want also to store the absolute value of the actual difference. Yeah, because we want to know how far is it from the actual from the target.
Yep.
Okay, that makes sense. Okay, and then going back to line 38, which might be a bit confusing. What I'm thinking is that it is going to be the maximum value between the response that we already have and the value where we at right now. So in the example that we have above, the first element would be -4. So at that point, we would say, okay, -4 plus whatever is returned from the function calling toSum with the subarray from I plus 1 till the end of the array, and we are looking for the target equals 5, as you described here in the example in line number 23. So yeah, that's what I'm doing here in line 38, because we are passing this new target to the toSum function, saying that okay, we are looking for k minus our current number, which in this case would be 1 minus -4, which it is 5.
Okay.
Yeah, what do you think about this? You think I should test it with a simple test case, something like that?
Yeah, I think this is something that you should do without needing permission. So definitely run through the test case, and I would suggest that every time you should run through the example that the question gives you, and then on top of that, come up with edge cases, which is what the interviewer mostly are interested about. Like what kind of cases that could cause a problem, and then if it does cause a problem, fix that as well. So like just that iterative process is something that the interviewer definitely looks for.
I see. Okay, cool. Okay, then let me take this as an example. I think it is small enough, I think.
Yep.
So let's say, so we're gonna start with -4, and as I said before, here in this for loop, we're gonna say, okay, -4 plus whatever it is returned from the toSum function, and we're gonna pass to the toSum function. We're gonna pass this subarray, and then we're gonna say, and in the to function, k is gonna be equals 5. So let's say now that
I'm going to pause here for a second. I think we can do better than what you're going through because this is going to be time consuming. Let's actually run the code with the input. For example, what I'm thinking of is calling this code with the input, right? So let's do that, like -4 or actually let's do the original input, -1 2 1 4, right? And then K is 2, right? K is 2. So let's run your code and K like that.
Okay.
Is that okay? Okay. So let's run this and then see if we get the right answer. Okay. So looks like we have a problem
list
here.
Is not defined again. What? Why? It is not. What? No, it should not be like that. Okay, let's try it, but I'm pretty sure that it is not correct.
Yeah, maybe we need some imports in order to do that. I don't know. Oh, okay. What if we switch to?
Or actually, we can just get rid of the types. They are not required. They are allowed, but they are not required. So let's just do that. Okay, let's see. I think this should work.
All right.
Infinite. Okay. Huh. Oh, because we are trying to return the maximum, and of course, nothing is going to be greater than infinite.
Right.
So at this point, we actually want the minimum, or
yeah, minimum sounds fine. What's wrong with minimum?
Yeah, nothing. Let's just run minimum.
All right, that's a sign of relief here. We got the right answer on this example case. Let's spend maybe 2 more minutes on test cases, and then we'll wrap it up with some feedback and then questions and stuff.
Excellent. Okay, let's say I'm sorry, are you still there?
Yeah, I'm still here. Yeah, I just got dropped off a little bit, but I'm here. Yeah.
I don't know what happened, but yeah, I'm here. Okay, let's see. Let's try with let me see what is kind of tricky here, or let's see if so we are looking for 3 numbers that equals to 2. Let's try something probably a bit simpler. Like what happens if we call it with a combination that can give us the exact target. So for example, here we can say what if we target 3. I mean, there is there should be the answer should be 3 here, and then we can say that something that is pretty like I don't know, like -10, and then that would give us like the 3 smallest ones, which would be like 2 minus 1, which is it would be actually the answer to this one would be 2 as well, but let's say that this is -2, so this will give us the sum of these 3 numbers. So let me just try these 3 examples, and see if we're getting what we're expecting. Yeah, I think they are correct. So I was expecting 2 in the second case and -2 in the third case because the closest is the sum of the first 3 numbers. So let me think about something a bit more tricky. What if all the numbers are, for example, negative, and we are looking for a positive number, like we are looking for 5. In that case, we want the 3 smallest, or the 3 largest, the 3 largest values. Which this is actually incorrect. I think the correct answer here should be -4.
Right. Okay, that's good. That's good that you are able to come up with a test case to identify a bug, and then you can fix it. But we don't have time to fix it. But I think that's a good kind of, even like in an interview, this would be a good thing because you're able to discover an issue with a test case. So that's scoring points in the unit testing part. I think it's about the time where we should stop here. I do want to give you some feedback and then answer any questions that you have. Okay. So let me kind of go through that, and I'll summarize it in the end as well. So don't worry, we're not taking notes here. I think you did a good job in the beginning. You are able to understand the question, clarify the problem. A couple of things you could do sort of as a bonus as well is to make sure to ask questions like, are there going to be, I'm going to put it on line 12 here. Let me just maybe put a section of feedback so that you have everything. I'll put it in line 36, feedback. One thing you could also clarify, and this is not like a requirement, but something to think about as well is anytime you're doing arithmetic, you always want to ask whether you will have a chance of going integer overflow. So in this case, you can ask whether the inputs would be, we would need to consider that, right? And usually the interviewer would say you don't have to worry about it. They all care about just the algorithm, but asking that question gives them the idea that you are thinking about the edge cases. And this is one of the edge cases to think about, right? Because when you're summing things, it could go overflow, right? So even addressing that would be easy too. You just convert everything from an int to a double or a long, things like that. So, but consider that, ask that question in the beginning. That will save you time in the coding, right? The other thing is, as you are describing the problem, you come up with your algorithms. You did a really good job explaining the complexity. And that's a good thing because we had this discussion, and then I was able to tell you can think about a better way, right? If you don't provide the solution, you just start coding, you're just going down the wrong path. And that way, even if you have the right code, the interviewer is going to look at that and say this is not the optimal solution. So it's really hard for them to pass you. So you did a good job by explaining your algorithm first, explaining the complexity, and by doing so early, you can have that discussion of whether that is the optimal solution or not, and then you can basically save them as much time as you can, and then continue with the coding, right? So your coding is going to be, that the coding is going to be optimal code if you have it complete, right? So that's a good part. So good job for explaining the complexity early, so that can drive the discussion, and then just confirm the coding, right, before you start coding. So that's a good part. And then as you're coding, obviously I think there were some minor issues, but as I kind of give you some hints, you were able to fix it. So I think there were two maybe occurrences where you show a little bit of hesitancy. One is the absolute value part, and the other is the max and min part. But those are fine because you're able to get it with some help. And you got I started with the correct solution until I see the test case. So at this point, I don't know where it went wrong, but I think it should be a minor thing, should be easy to fix. But it's okay to make mistakes and then discover them yourself and then try to fix them. We don't have time today to fix it, but I think, given 5 to 10 more minutes, you should be able to address that problem, no problem, right? And definitely be aware that if you are doing your interview in a platform that allows you to code, they expect you to run the code, right? So you don't have to do the manual testing that you were going to do. In some companies like Google and Facebook, you would do that because they don't have a compiler, right? But in some other companies, for example, Microsoft, they actually have they use Codility, and that expects you to run the code. And some other companies as well. So obviously, a lot of companies use CodePad like this one here, but just make sure that if it's available to run the code, you should run the code, and always run it with the example case first, and then come up with the other case. Right. Okay. So on the unit testing, I think you did a good job. The first discovering the bug, that's very important. That means that you have considered some cases. But one more thing, a couple more cases that I thought you should include as well is the case where there's 3 elements, right? That is sort of thinking about the bounds of the input, right? So the most common use cases would be like to invalidate input, right? Make sure that what if your input k is a negative value? What if you have an empty array? These are things that you can just call out. You don't really have to do it because they expect you to know this. But then the edge cases is where, like, what if the input is only 3 items? What if it's really long? So you have to think about different things. And what if the values are close to the upper bounds of the integer array, integer type? These are things that you should always think about too, especially when you're doing arithmetic, right? So that's one case, and I think the whole idea of negative and positive values, I think those are good. That's where you address that in line 76. That's great. So yeah, I think if you have the cases that I mentioned, I think that would make the unit testing much more complete. There might be a couple more that I can't think of right now, but if you have time, you'll be able to think about that during the interview. I think that's all I have for feedback. Do you have any questions or maybe feedback about this question, what you like, what you don't like, anything like that?
Yeah, well, honestly, I really like the question. I liked it that it is not like one kind of those questions that like there is just one correct answer, and if you don't know it already, it is like pretty much impossible to get it. I did like the question. It is also, it encouraged you to think about many different approaches. So I definitely like that. Something I wanted to ask you is, I don't know if it is okay to hesitate. Like, for example, at the very beginning, I hesitated about the right approach, because I knew that, well, at the very beginning, I didn't know how I was going to solve like the original problem of like getting the closest one, but I knew that I could do something about what happens if we want the exact target. So I don't know if that is a good way to start, or if you could recommend a different approach of like forget about that and try to think about a completely different approach, or what do you feel about what the path that I followed?
Yeah, I really like the approach you took, especially like you said, if you don't know how to solve a problem, you definitely want to simplify the problem first, right? And when you simplify the problem, I think that can facilitate a discussion, right? The interviewer is going to help you try to think along the direction that should lead to the solution, right? And I think whenever you start the problem in a simple way, or maybe a restricted version of the problem or subproblem, the interviewer will help you along the way, or you can have a discussion. And I think that's really where the interview is evaluated on, is can you take a hint and then make progress, right? If you know the answer right away, there's very little the interviewer can know, right? But they don't know whether you memorize the solution, you've seen it before, you just regurgitate. It's very good to see that, hey, you don't know how to do it, at least you have a good approach, right? That's a good way of doing it. So I really like that, starting with a simpler approach. And then I thought the discussion that we had helped you get to the right approach at the end.
Yeah.
So I think that was good. Yeah. I would say that if you were to do some more practice, here's another problem that is very similar in style, where you want to break the problem into simpler parts and then try to do a harder, like solve the problem later on. So Another problem would be the regular expression matching, where you have to match the star and the dot, star and then the dot, right? And so, for example, A dot C would be matched to ABC, right? And then A star C also matches to ABC because the star means anything, right? Any zero or more items, or more. Sorry, star means zero or more. A dot means any one character, right? Matches any one character. So for a problem like this, you might want to say, well, I'll just start with handling the first case, the dot case, and then once I handle that, then you can try to extend to handle the star case. And that's the problem that I also suggest that you can try it out on your own to kind of develop the habit of solving a simpler problem of the overall problem and then extend it.
Yeah.
So yeah, just coming back to answer your question, I think you had a good approach.
Okay. Makes sense. No, that's perfect. Can I expect some questions at this level on an on-site interview?
I definitely do think so. But I think this question is more of a 1 hour type interview as opposed to a Facebook question like 20 minutes. I think those are more shorter. Those are more like one loop. You solve a problem, either use a data, use a map or use something else. This is one where I think you can see there's like around 20 lines of code. I think a normal question that's done in 20 minutes is about 10 lines of code, in my opinion. So this one I would say is more of a 1 hour interview question. And this is a popular one as well. So it kind of branches out from the threesome, right? You can do a threesome, you can do the threesome smaller, threesome closest in this case. And I think this is like a family of problems where you can get a lot out of it. Sorting it in the beginning and then different like two-pointer approach. So there's a lot you can get out of this question by all the different techniques. And unit testing can kind of get you thinking about arithmetic overflow. So that's why I like this question a lot when I see this question. So that's why I think it's very popular. It's very easy to understand too. Like, right now a lot of people are doing interviews online, so you cannot really draw a graph and explain how to do it, or draw a binary tree out. So you see a lot of problems that are more just array based. So I would put my money on kind of array based type of questions and kind of focus on that.
Okay. No, that's a good tip. No, that's it. It was excellent. It was an awesome experience. I learned a lot. So thank you very much.
All right, good. Good luck for your interviews. And thank you for using interviewing.io.
Thank you very much. Have a good rest of your day.
Yep, you too. Bye.
Bye.